Now today I want to continue our lesson with linear function and show you how to graph a function using the x and y intercepts. Now I need to first define what they are. What is an x-intercept and what is a y-intercept? I think the best way to represent it is to draw a picture. Okay, so pretend I have a graph like this, and let's see if I can actually use a different color here to show you. I have a line going through. So let's kind of label this. Can you see that okay? Yes, you can. Okay, so I have a line. Let's say a line going through these 2 points. Remember, I only need to have 2 points to make a line. So let's say the line is going through these 2 points. Notice that this particular line, if you can kind of see it, I'm trying to darken it a little bit here so you can see. This particular line crosses through 2 points, but more importantly, it's crossing through your y-axis and it's crossing through your x-axis. Okay? The point on the x-axis where the line is crossing over, right there, since this line, your function crossing over x-axis is called the x-intercept. Okay? And the point where your line is crossing over the y-axis is called a y-intercept. Now, let's try to pinpoint that particular coordinate right there. What is the x-intercept over here? How do you get to here? Well, you have to go 1, 2, 3 over to the right hand side. So you write that, but then I did not go up or down, so it's going to be 0. Vice versa, if I'm going to go to the y-intercepts, I need to go nowhere, left and right, and I need to go 3 up, right? So for that coordinate, it's going to be 0 because I'm not going horizontally, but I will be moving 3 up. So if you see very carefully, I'm just going to show you another one right here, side by side. It's just another one. Watch. Pretend I have another line going through these 2 points. Okay, so of course this is your y-intercept because it's crossing over the y-axis, and this is the x-intercept because it's crossing over the x-axis. If you were to name the point, it'll be 0 because you're not moving left or right, but then you went 3 down, so it's going to be 0, negative 3. Over here, it's going to be you going 4 left, but you not move up or down, so it's going to be negative 4, 0. What do you notice about the two function that I just graphed? As you can see, x-intercepts, they both have what? Y-intercept, they both have what? Okay, so if you examine closely, the x-intercepts always have what? They both have zeros on the y component. Okay, the x-intercept always has 0 in the y component, so it's always going to look like this. Okay, versus the y-intercept, in the x part. So it's the exact opposite, as you can see. So for the y-intercept, you would have 0 for x and whatever value it is for y. Okay, so why is it so important for you to know the x and y-intercept? Because, as you can see, you can graph any 2 points using the x and y-intercepts. So instead of doing table, you can use the x and y-intercept to graph your line quickly. Okay, so let's pretend I give you this. Let's say that 4x minus 10y equals 28. If you were to put in a table form, you would have to solve for y. Okay, so you're going to move the 4x divided by negative 7, which can take a bit of time. Now, if you want to go the x and y-intercept style of graphing, so this is just a second way to graph the same exact line. Okay, so if you were to do that, you would to split into two pieces. First, find your x-intercepts, and then go and find your y-intercepts. Remember, for x-intercept, what is the condition? That y will always be 0, right? We just find that. And then for y-intercepts, x will always be 0. So all you need to do is go back to your function and substitute for x-intercept, you substitute y equal to 0. So then your function now would look like this. See it? And you solve it. 7 times 0 is still 0. So what you got now is x equals to 7. And then the format for the x-intercept is 7, 0, right? So you got yourself a point. Over here, if you want to solve for it, you would do the same thing, but this time you substitute 0 into x. So it's going to be 4 times 0 minus 7 times y equals 28. This will go away. So now when you divide it by -7 both sides, y is -4. Okay, so that means the point now will be 0, -4, okay, because this is for y. So 2 points, I can certainly use the 2 points to graph. 7, 0, so you go 1, 2, 3, 4, 5, 6, 7, and I'm not moving up or down, so there it is. And the other one is 0, -4, so no horizontal, but down 4. 2 points, and I can quickly connect these to get a line without having to create a table. Okay, remember, you can always still use the first technique, which is creating a table to graph the exact same line. Just kind of keep that in mind. Let's try one more example here for the x and y intercepts. So let's take a look at this one right now. Okay, so let's say I have that, it should be y. I want to use the x and y intercept to graph this. So I would split into two problems again. X-intercept, y equal to 0. And then for y-intercepts, x equal to 0. So it's always the opposite of each other. So now, y equal to 0, so I'm going to be -3x plus 2 times 0 equals to 12. This will go away, so it's going to be -3x equals to 12 divided by -3. X is -4. Okay, so then the point here is -4, 0. Over here, if I'm going to substitute x with 0, it's going to be -3 times 0 plus 2 times y equal to 12. This will go away because it's 0. So 2y equals to 12 divided by 2. Y is 6. So my point for that one is going to be 0, 6. Watch for the format, okay? This is y-intercepts. So that's why x is 0. This is x-intercept. That's why y is 0. So you got the 2 points. I can plot these. It's going to be -4, 0. And it's going to be 0, 6. Got my 2 points. I can connect them again, and that would give me my line. Now please understand that not every function is good for the x and the y-intercept form. Sometimes it's quite difficult to use the x and y-intercept form, and you might have to use another technique. But for now, I show you two ways to graph a line. Using a table, which requires you to solve for the dependent variable, or using the x and the y, then that doesn't require you to solve for the dependent. You just basically substitute 0 into x and y, depending on the cases, to solve for each point. Okay, so try to review that, and if you have any questions, please come back with that tomorrow.